And thank you to Jean-François and team for inviting me to give this talk. Yes, you will see that it's a very different perspective, and my main message will be that applying agroecological principles, and I will tell you more on what are agroecological principles, but applying agroecological principles to animal farming system can foster transition towards more sustainable food system. And there are many authors on this first slide, coming not only from INRAE in France, but also from Wageningen University in the Netherlands, from Belgium, Spain, Bulgaria, and Switzerland, because we all team up in a Horizon Europe project that is called Agroecology Transit. So I can go fast on this. You know, this debate, animal production system contribute to improve human condition. They provide proteins, but not only proteins, a number of also micronutrients. They provide jobs. These are global numbers. But they also provide manure, which is particularly important in the global south. They produce drought power. They produce iconic landscapes. And you know that there is a bat related to greenhouse gas emissions, especially methane, the use of land to produce feed that are given to some animals, especially poultry and pigs, that can also lead to deforestation. And also for some ethical reasons, some people say that they don't want animals to be killed for them to eat, which can be something that we can all respect. And I will try to convince you that agroecology is among the most promising options to achieve food system sustainability among the land-based options to produce meat, milk, and eggs. And when I started to work on that 12 years ago, one of the first papers I read was from Alexander Wessel. And if you read this very well-known paper, you will understand that the term agroecology is not very new. It can be tracked back to the 30s. And it has been used to refer either to a scientific discipline or to a set of agricultural practices, but also to a social movement. As a scientific discipline, agroecology applies ecology theory to the design and management of sustainable agroecosystem, and this definition has been expanded to the entire food system. And it aims to stimulate natural processes to design agricultural systems that are weakly artificialized and that are thus less dependent on inputs, that are productive, that are environmentally friendly, and that are socially fair. Why? It has taken quite a long time to have the animal production system being part of the agroecology family. I think part of the story comes from a lot of agroecology was born in Latin America, where agroecology, where cattle farming in large farms is often associated with problem of deforestation and also of land grabbing by these large farms, and was thus considered by the initial proponents of agroecology to be outside the agroecology scope. In this big book that was published several times, but it was led by Stephen Glissman from the University of California, there's only one chapter dealing with livestock production. And what is written is that the problem lies not in the animals themselves or in the consumption of animal products, but rather in the way they are integrated into agroecosystem. And the key point is that frequently in many specialized systems, they were no longer integrated. And that thus, understanding the integration of the animal in its agroecosystem provides levers to ensure sustainable environmental and economic concerns. So when we started, we realized that there was no framework that was really adapted to animal production system, and therefore this was a fantastic team work, and our goal, we first decided to propose principles that can be used as guidelines to implement combination of agroecological practice that are adapted to local conditions and that can apply to a wide range of animal productions. These 5 principles are, the first one is related to animal health. We think that we should achieve integrated animal health management. We should decrease the external inputs needed for production, and by doing this, we aim to limit feed food competition. We should decrease pollution by optimizing what we call the metabolic functioning of farming system, which is basically related to recycling. We we think we should enhance functional diversity within animal production system to increase their resilience, and that understanding a farm or a field or a grassland as an ecological system, it gives us levers to preserve biological diversity by adapting management and at farm or landscape scale, based on ecological theory. And in this first paper, we showed that you can apply these principles across a wide range of animal production systems. We took some examples from a dairy system, a grassland-based dairy system in Brittany, an integrated aquaculture system in Southeast Asia, and a rabbit production system. And you see that you don't have the same relative importance of the different principles, but the same principles can apply. You also see that not only one principle applies in each system, and really agroecology calls for holistic or for systemic approach, and sometimes to a transformational approach. More recently, there have been people, starting from a high-level panel of experts from FAO, have proposed a consolidated list of 13 generic principles as part of a transition pathway to more sustainable food system. What is different here is that they not only consider animal production system, but all type of agricultural system, and they not only consider the agroecosystem, but also the food system. And it's very directly related to the 10 elements of agroecology that were presented earlier this day by Anne, and in this paper by Alexander Wesel, there is the explanation on how they relate. As I'm talking about principle, I mainly refer to these 13 principles, while the 10 elements of agroecology can be very useful to evaluate in a multi-criteria approach different farms. So you see that two of these principles are also central, the one on synergy and the one on co-creation of knowledge. I will not tell you the whole story, but the message is that they are related. It's not completely different story, but as they consider all types of system and also the food system, new principles were added. Some are very directly related, those related to animal health or those related to recycling. Of course, as it's supposed to apply to a wider range of systems, soil health becomes even more important. And the principle related to diversity as a lever for resilience can be found in three different principles. The one on synergy, which is really focusing on ecological interaction. The one on economic diversification, but also the one on social value and diets, where we aim to build food systems that provide healthy, diversified, and culturally appropriate diets. And same for the biodiversity principle. There's the ecological side, and the last principle, land and nature resource governance, deals with how smallholder farmers can be considered as the guardians of natural and genetic resources. And there are four more. Fairness, which is similar to what we know for organic farming. Connectivity, which can be defined as the re-embedding of systems into local economy. Participation, that is related to the promotion of decentralized governance and local adaptive management of the food system. And the last one that is very important is the one on co-creation of knowledge. And co-creation of knowledge, which means that the knowledge we use in agroecology is not only science-based knowledge. We have a real interest for the knowledge that is produced by farmers locally, and co-creation of knowledge between farmers, scientists, NGOs, and also sometimes citizens aim at producing actionable knowledge that can support decision-making and facilitate transition towards more sustainable animal production system. And when you talk about co-innovation, you talk about three things: a system approach, because you consider the complexity of a system, emergent behavior coming from this complexity. You consider that these systems are nested into socio-ecological systems, And you also consider social learning, which means you give value to the perception of each stakeholder's priorities and values, and you start to understand how the different stakeholders interact. And you also do monitoring, because you change the system and then you will record. That's why the tape principles are most useful. You will record how change in the management, change in the priority of the system will change the performance of the system. And you go to learning cycles and back to adaptive management of the food system or farming system. So I'm now ending with this more theoretical approach, and will tell you that I will illustrate this principle from 5 out of the 11 innovation hubs that team up in the agroecology transect project. 3 are purely grassland-based in French Massif Central, in Switzerland and in Bulgaria, and 2 are integrated crop livestock systems in Andalusia, in the south of Spain, and 1 in Guadeloupe in French West Indies. Like this, we cover also a wide range of bioclimatic conditions. Integrated animal health. It can be seen as a 3-pronged strategy. First, you can have some preventive approach to before you have the animals outside. And for instance, you can feed the animal with sainfoin before having the sheep outside. And because of the condensed tannins that you can find in sainfoin, it will protect them from some of the gastrointestinal parasites. And there are you can also use some other plants like chicory, for instance, in forage mixtures. Then I would like to talk about another process that is called the dilution effect. What is the dilution effect? It comes from the idea that goats, sheep, horses, or cattle usually have different parasites. And if you do mixed grazing with, for instance, on this picture coming from Guadeloupe, cattle and goats, you see if cattle and goats don't have the same parasite, part of the parasite cycle is outside the animal. And when the goat is extracting dungs with parasite larvae, if these larvae are being consumed by cattle that are grazing with the goats, they will come to a dead end. They cannot evolve in the body of a cow. So that is called the dilution effect. And then the third, and on this slide you see that it's working. That's an example coming from Guadeloupe. On the right side you've got the control, 100% goat grazing, and when you mix them with cattle, you see that the goats are less infected. And the third idea is that you can also treat animals, not all the animals. You can treat animals selectively. For instance, in Guadeloupe, for small ruminants, they're looking at animal eyelids to determine which animal should be treated. And doing this, you use less products, and it's also good for the farmers to pay less for veterinary products. And you can also use phytotherapy. And in this reference, you would have some real values, for example, on the effect of giving banana leaves as a complement to veterinary products. In Bulgaria, they graze animals on willow. Willow is also has some components which are the basis of aspirin. They also graze them on this plant. So this plant also contains salicylic acid. And what I find even more surprising is that in Bulgaria, for example, local farmers sometimes give mushroom to their sheep. And what I found even more surprising is that, discovering that, I found in the literature that there is some evidence that there are also anti-helminthic some fungi that produce spore, and that in some veterinary products, you give this spore to the animal, the spore will evolve in the body of the animal, will produce mycelium, and in the dung, in the feces, this mycelium will directly kill the nematodes. So you see that you can find some ecological basis behind this. This is quite classical, but I start to give you another example coming from Switzerland on the benefits of multi-species mixture. On the right part of the slide, you see that if you increase plant diversity, in this case from 1, 2, or 4 species in the mixture, not only you increase the grass yield, so the reproduction. It also occurs in the drought condition. But if you look at the vertical bar, you see that the vertical bar, that is standard deviation, is also lower in the fourth species mixture. So you see that this mixture are also more stable in terms of grass yield, and it's related in this case in the fact that there is some asynchrony in the growth of the different plant species from this mixture. And in synergy, in this system, they develop a real synergy between farmers, research, and seed company, because part of the gains from the label are also invested in variety testing and development of new mixtures, and they produce a number of locally adapted management proposals to fight against some of the weeds in this mixture. And if you go on this QR code, you will have one of these examples. Diversification can also occur at the farm scale, and this picture is a picture from Guadeloupe, and the idea is to develop highly diversified micro farms. The idea is to have one family living from 1 hectare behind this. And in this micro farm, there's a huge diversity of plants and animals, more than 30 cultivated plant species with cultivars that are selected for improving drought and pest tolerance. And in this system, animals allow valorizing co-products and fallows while also providing manure to the system. And this is just the result of these experimental farms compared with some regional values, and you see that there are clear benefits in this case on farm autonomy, on gross margin that are twice higher, but also on some environmental dimensions, on organic carbon and greenhouse gas balance that can even become negative. One problem with agroecology, or one real issue, is that it takes time to manage this diversity and also to monitor the system so that the farmer can benefit and really value this interaction. And you see that not only labor, but also labor productivity is lesser in the agroecological diversified microfarm. And one thing is that, for instance, as this farm is also an organic farm, weed management is estimated at 30% of workloads, and they develop innovation to deal naturally with these weeds, which can be, sometimes they are not related to the animal. Recycling of sugarcane straw and banana leaves can be used for mulching, and sometimes you can just use grazing animals to deal with the weeds. And the interest also is this highly diversified farms with including different strata, including trees, is that they are very resilient, including to extreme climatic events like hurricanes. Now I'm moving to Spain, and really it's in the south of Spain, and in this case, researchers and farmers are working together with the local agricultural officers to explore opportunities for local small-scale slaughter units and transformation unit of meat and dairy at public infrastructure. It's an area where there is Iberic pigs that are important. And so it's not only dealing with farming practices, but we also have to integrate sales and product transformation. In this case, also extensive multi-species farming with ruminant and Iberian pigs can be used to control shrub vegetation under chestnut trees. And they really engage with all stakeholders, not only farmers, farm advisors, but all the whole community. And also they try to develop some artistic approach to overcome cultural, political limitation. And this relates to some of the principles I mentioned earlier: social value and diet, connectivity, participation, with a global idea that they want to retain added value within the region, which has also social benefits. Some elements related to biodiversity. I mean, it's not just because it's green and beautiful that it's agroecological. You can think on agroecological management of grassland because you understand the ecological processes that occur in this grassland-based system. And there are two hypotheses. One is habitat heterogeneity hypothesis. A heterogeneous grassland has a higher habitat value for insects and birds. And the second hypothesis is the trophic hypothesis. The more flowers, the more bumblebees, wild bees, butterfly. And just this slide is to show you that it's it can work. In this system, we developed what we called an ecological rotation, where you prevent animals to graze some of the plots at the time of the peak of flowering. And doing this, you have twice more flowers in the field, and doing this, you have butterfly species richness, which is also multiplied by 2. And in the case of Bulgaria, they are really in a high nature value area, and the focus is on establishing a fair and common governance of grassland system, which is also viable for dairy cattle, dairy sheep, and beef farmers while preserving and benefit biodiversity. And what they did is they did an amazing YouTube video showing interviews of local farmers about their willingness to practice this type of animal farming and how it can benefit wildlife and preserve landscape. This was made in collaboration with the Bulgarian Society for Protection of Birds. And globally, this idea brings us to the idea that to preserve this system, we also need to change regulation from local, but also at the European level. At the local level, they deal with changing the rules for using municipal grassland in favor of livestock farmers. And at the European level, the challenges are related to securing high nature value farming in the current and future CAP. And all deals with the principle of land and natural resource governance. The last frontiers, the last challenge also is to incorporate citizens in this approach. And because in this, there are big controversy within the farming sectors, we think that also to have consumer, that it's very important to also have consumer to be part of a learning process. And frequently it's not the case. And what we did in France, it will be my last example, is that we are adapting existing methods that we are developing in the industry, this is the KCP method, to promote horizontal dialogue between dairy farmers, citizens, and researchers. And by doing this, we promote a dialogue between two spaces, which is the knowledge space and the concept space. The knowledge space is what we all know, that is already well known. I will take an example. I want to make a new type of camping chair because you know that camping chairs are usually heavy in the back of your car and they're usually ugly. So what is a chair? It's something that has 4 legs, like you can see it. But if you explore other options, you can also imagine other way of thinking. And in this case, you go to this other option that there are also chairs that don't have any legs, but usually they're very heavy. So it's not really suitable to bring this type of chair for your camping. So you change the question and you want to do a chair with few material. And at the end, you can come to this type of chair. So I don't know if you like it or not. It's not really a problem. I just show you that this type of methodology can make you can bring people to think out of the box. And really, when we want to talk about the sustainability of the livestock sector or of agriculture in general, we need to think out of the box to solve some of the forthcoming challenge. And we use it in different ways. In the case of the future of dairy farms in upland area, it can be used to promote the dialogue. The second point is more interesting. You can share value related to dairy farmers. You can have a researcher who can explain you that it's good to kill veals relatively young. It's good in terms of life cycle assessment because by doing this, they will not consume forage, they will not emit methane, and overall, the performance of a system where you kill the calves early are better from a life cycle perspective. And you can have also consumers that tell you that answer that slaughtering young animals is not ethical. And in the case of what we did in the French Massif Central, we did a number of sessions by using this concept knowledge methodology. And in one group, there were 2 citizens and a researcher who said really killing young animals is a no-go zone. And so what did the group do? The group was composed of also farmers, farm advisors, over citizens, over researchers. And so they tried to think out of the box and to find some solution to raise the age at which cows are slaughtered so that they can live longer. And in this case, I could go into more detail, they proposed something that is really out of the box, that is a cooperative intergenerational veal fattening system where veal cows are raised by nurse cows that are also intended for culling. And this is the products are sold by the local cooperative composed by, that is led by dairy farmers and whose products are sold locally. Again, we came to solutions that are not only related to biotechnical practices, there are also organizational levels and also the selling and transformation components. And that's, I will be very short, and also not only citizens and don't have the same expectation, but sometimes they don't have the same knowledge. And as they don't have the same knowledge, it's difficult for them to team up with researchers and farmers because they cannot talk at the same level. And what we did is that we developed some games, some serious games, as tools to support the transition of agricultural system. This particular game is based on a quite simple representation of farming system at the interface of different environmental, economic, and social dimensions, which are market, employment, inputs coming from outside the territory, environmental impacts on water, biodiversity, and also social values. We build this framework, and we use it, we develop it as a serious game. And what is very interesting in this game is that first it reveals trade-off. You see on the framework that there are green arrows and red arrows. And I think if we want to, as I'm an animal scientist, but if we want to talk to the society, we have to acknowledge the services provided by the livestock farming system, but also to know and to be clear about their environmental impact. It's not, and we build this type, we call this tool a barn, and when we applied it to a range of animal production areas across Europe, you see that there are no areas with only green arrows and no area with only red arrows. So it tells you about the complexity. And while representing the system, players have to agree. They have to come to a common goal. And by doing this, they cannot just say, no, that's not good to kill the animals. They have to negotiate. They have to explain their values, their priority to the other. And as it's a game, it's made in a safe environment, and it decreases the asymmetry of power, the asymmetry of knowledge. That was my last example. I see you, Alexander. And the take-home message are thus that agroecology provides a scientific and operational framework for moving animal production systems towards more sustainability. That we have proposed principles that are generic and that can be used as guidelines to implement herd management practices that are locally adapted. Animals, in some cases, are most useful for this agroecological transition for different reasons: nutrient cycling, biodiversity conservation. Co-creation of knowledge between farmers, scientists, NGOs, and citizens can promote horizontal dialogue so that collective decision can emerge on locally adapted transition. We have tools to do that, and presented the TAPE tool, which is a way to analyze the degree of convergence of livestock farms or all type of farms with agroecology. And I show you some example at the end of my talk on tools that have been developed to facilitate stakeholder dialogue. And I think that overall, these innovations that account for farmer and citizen preference and also ethical values are more likely to put the animal production sector in a better position to cope with forthcoming challenge. And I thank you, and this is some advertising if you want to follow the Agroecology Transect project.